Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
Longitude and latitude. By the way, these are imaginary lines on the earth, surface of the earth, just to show points on the surface of the earth. The longitudes are the vertical lines, while the latitudes are the horizontal lines. Yeah, longitudes are also called meridians, right? Let me just take it, let me see where this is talked about. All right, these longitudes are called meridians, latitudes are called parallels. Are you listening?
Yes.
Okay. The horizontal lines, like all these ones, latitudes, also called parallels. The vertical lines, like all these vertical ones, are longitudes. So the equator is what? Is the equator a longitude or a latitude?
It is a latitude.
Yeah, latitude. In fact, the equator is the biggest latitude. You know that?
Yeah.
Biggest latitude. If you notice, latitudes decreases in value as you approach the north or as you approach the south. The latitude is biggest at the equator, and it keeps getting smaller and smaller and smaller and smaller and smaller, right?
Yeah.
As you're going towards north or south. So the circles of latitudes are parallel to each other, or parallel of latitudes, and the equator is the biggest latitude. We'll give it latitude 0, which the one at the center. Now the equator is 0. Now as you go towards the north, the angle increases from 1 to 2 until you get to 90. Do you understand?
Yeah.
That's 90 north. As you also go to the south, you start from 0, the angle increases from 1 to 2, 1, 2, until you get to 90 south. Do you understand?
Yeah, I do.
This is 90 north. So how many lines of latitude do you have? These are simple questions you can get in something like JAM. How many lines of latitude altogether?
7.
Hmm?
7.
I don't know where you're getting this yourself from.
Wait, is it not 90, 67 point
What I'm saying is,
25
I said from the equator, that is 0. You start counting from the equator, which is 0. As you go to the south, you count up to 90. From 1 to 90 south. Also from the equator,
Oh.
as you go to the north, you count 1 to 90. So altogether,
Yes.
how many lines of latitude do we?
180.
180. So 90 in the north, 90 in the south. Altogether 180, right? So 180,
Yes.
total of 180 lines of latitude. And the biggest is the what?
The biggest is the equator.
Which has latitude of 0, right?
0.
0 degrees.
Yeah.
Interesting. That's for latitude, parallels, horizontals. Now when we get to longitudes, we call them meridians. Meridians. Are you listening?
Yeah.
Longitudes are meridians. You have some to the west and some to the east, starting from the middle too. The middle is the greenish meridian. Hope I got the spelling correctly. Greenwich is just a town in the UK,
Yeah.
which is 0. Greenwich is 0. So to the west, you have 180. That's from 0 to 180 in the west. 0 is the Greenwich, so after 0 we have 1, 2, and so on. You understand what I mean? So
Yeah.
1, 2, until you get to 180, the highest, west. Also, you are going towards the east, you start with 1, 2, until you get to the highest 180 east. So altogether, how many longitudes? Remember, longitudes are called meridians, the vertical lines.
So
So
we have 360.
altogether 360 meridians, total of 360 lines of longitudes. Longitudes or meridians. Okay, all the lines of longitudes are equal. Total of 360 equal lines. Let me just put it equal so that I don't have to write the sentence again. Equal lines of longitudes or meridians. You remember?
Yeah.
By the way, I told you that for latitudes they are not equal. The biggest latitude is
It's the equator.
equator. Other latitudes are smaller. You know, the smallest will be 90 degrees south and 90 degrees north. They are the poles.
Yeah.
It gets smaller when you get to the pole, north pole, and south pole. That's for the latitudes. All right, but all longitudes are equal. All the 360 lines of longitudes or the meridians. In fact, the equator is equal to the longitudes. So the equator is also called a meridian. Did you hear me?
Right.
The equator is
The equator and the latitude.
equator is a latitude, but because it is as long as a longitude, it is also called a meridian. So let me just put it here. Let me write it in a different color. Let me write it in purple. The longest latitude is what again?
It's the equator.
Is the equator. And it is equal to what?
It's equals to
The longitudes. It's equal to the longitudes. You know, it's also the same as, it's equal to the longitudes. Therefore, the equator is also a meridian. Therefore, the equator is what? Equator is also a meridian, isn't it?
yeah.
Please read what I wrote. A meridian.
Total. Okay.
The longest.
Longest latitude is the equator, and it's equals to the longitude. Therefore, the equator is also a meridian.
All right, the equator is also a meridian. So the meridians are all lines of longitudes and the equator. Other latitudes are not the equator because they are smaller than the latitudes or smaller than the equator or the lines of longitudes. All right. If you know this, you are good to go. The only thing you need to know is, let me just tell you, remember, by the way, you can get more of some of these things from these textbooks, regional maths, SS3, multipurpose maths, and different other textbooks. So this is just a review. Longitude and latitude. Okay, you need to know the common part of a circle, just the common ones that we need. If this is a circle, because all of these things are about circles. If this is the center, what do you call this distance? Okay, what color can I use so that it can come out well? Let me see. Oh, blue doesn't come out well. Let me see. Will purple come out well? Okay, I think it's trying. It can come out. Okay. Let me, from here to here. Let me make it better. I want to make it better. Just a moment. Let me make it better. I already have this diagram, so why am I drawing? Okay, since I started already, let me just tell you what I did so I don't waste time. What do you call this length, A to B? What's the name?
It's called an arc.
An arc. Arc AB. What's the length of an arc AB? If this place is theta, what's length of arc AB?
Theta times radius.
This is your further maths. You think everybody does further maths? Okay, what's a simpler one all of us understand? You're using your further maths to threaten us. Okay. Not everybody does further maths. Yes, theta times radius, but that theta must be in rad. That's also correct. Did you hear me?
Yeah.
If you're using theta times radius, it must be in rad. I understand what you mean. Length of arc is r theta, but the theta must be in rad, okay?
Yeah.
Arc AB, length of arc AB. If you're working in rad, is equal to r theta, But if you're not working in rad, working in degrees, what is the formula?
Theta over 360.
Beautiful. Theta over 360 times circumference, which is 2 pi r. Beautiful. Okay, so that's all we need, 2 pi r. So since this is about the Earth, the r will now be the radius of the Earth. Let me just tell you why I'm saying that. Look at this, for instance. This thing is so easy. It's so easy. Once you know your stuff, you are good to go. There's nothing in this. For instance, A to B. Look at A to B. For instance, from here to here. From here to here. This line is I'm going to write it in green, in red. This line is what is the name of this line? What's the name of this line? Is it a longitude or a latitude?
Oh, it's a longitude.
It's a longitude, So if you're measuring A to B, how far is A from B? All these things must be known for people who ask, pilots and all that. They need to understand lengths of distances from Earth, and all that. So it's actually a well applied branch of mathematics. Even your what is it? Your geography. So let me tell you something. This place is 25 degrees south. It's on a latitude. Let's just even start with that. Latitude of 25 degrees south. As you can see, Why this one is on a latitude of 15 degree north. Did you see that?
Yeah.
15 degree north latitude. And all of them are on a longitude of 60 degree west. It's so easy. What is the angle separating A from B? What's this angle? I will draw it out for you to see. Look at it. Let me draw it out for you to see. You see how interesting this thing can be. I'll draw it out for you to see. What's the angle separating A? This is A, this is B. From the equator, which is this imaginary line, this place is what angle? As you can see, 25 degrees. While this other place is what angle? As you can see, 15 degrees. A is on a latitude of 15 degrees north. B is on a latitude of 25 degrees south. And both of them are on what longitude? Oh, sorry, this is actually east. Oh. This is actually east. This is to the east. Are you still with me?
Yeah. So that would be
What's the angle
50.
separating? What's the angle separating A from B? I will use a blue line to draw it. The angle separating them, theta. This theta is what?
40.
Say it again.
Is it 40?
15 plus 25. You are absolutely right. 40 degrees. So if you just know the radius of the Earth, you can find the distance A to B. You see that it's so easy?
Yeah.
That's just it. Once you know the radius of the Earth, you can find the distance between A and B. Without wasting time, what is length AB? First of all, let's get this value because it will always be provided. What's the radius of the Earth? Approximate radius of the Earth
63,000.
is approximate radius of Earth R is about 60 what? 60,000 kilometers.
Yeah.
You can put it in meter if you like. Circumference of the Earth, sometimes they may give you in circumference.
It's about 40,000.
Circumference.
40,000.
Circumference of Earth, if you like, C is about 40,000. 40 what?
1,000.
What did you say is the radius of the Earth again?
60,000.
It can't be 60,000 and circumference 40,000. Confirm again.
I meant 6,000.
Have you confirmed it properly?
Yes. Yes, 6,000.
Radius of the Earth is 6,000. It will always be provided for you whenever you're solving this anyways. While the circumference of the Earth is what?
40,000.
But even if you didn't know, you can easily get that from simple this thing. Because circumference is 2 pi r, isn't it? That's also how we can get it. We just use 2 pi r and get the value. Alright, so since you know that, you can easily know the length of AB. Wait, what are we solving? This is it, isn't it? So what's length of AB now? Length
40
of
over
AB
60.
is equal to the angle theta, because length of an arc is theta over 360 times 2 pi r, where r will be the radius of the Earth. That will be now 40 over 360 times 2 times pi times 60,000 times 6,000, isn't it?
Yeah.
2 times 2 times pi times 6,000. Why 6,000 is the radius of the Earth? Radius of Earth equal to 6,000 kilometers, approximately. Okay? What did you get?
Yeah.
Do you have your calculator there?
Yes, I do.
Alright.
That would be about 4,188.79.
4,000. Put it in three single figures.
4,180.
4,180
Yeah.
kilometers, right? Is that what
Yeah.
you go 4,180 kilometers? All right. See, I just need you to understand. I don't even need to say much about that because it is obvious. It is obvious. If those latitudes are on different parts of the earth, you just add the angles. But if they're on the same part of the earth, you subtract. I want to say it again. I explained to you what I mean by that. Let me show you what I mean by that. It's not really a big deal. You can easily get that. So let's first of all do that of latitude before we do this. Where is it? Okay. Watch me. Are you listening?
Yeah.
Look at this. This is the equator. All right.
Yeah.
Let me put this angle. I'm going to put it in purple. I told you this thing is so easy. So easy. So easy. Let's see this one here. And then this one here. Right? Okay, let me put this one in green so that you can see, or maybe blue. What color? Okay, green will come out better. Green will come out better. Green will come out better. Let me shade it. Are you seeing it?
Yeah.
Okay, let's call here. You're going to see how easy these things are. Let's call here A, or maybe a different letter A, and call here B. Call here B. Or can I use letters that are not, maybe, so it doesn't tally with what is written in the lesson notes? I'll just call it P and Q. P and here Q. All right. Do you notice that they are on the same something? P and Q are on the same something. Same what?
Yeah.
Same what?
Same longitude.
Beautiful. P and Q on the same longitude. Longitude of what? You can see it. P and Q. P positions P and Q, positions P and Q are on the same longitude, right, isn't it?
Yes.
On the same longitudes. What are that same longitudes? Which is 30° west. Isn't it? It's on the west. You remember your Cartesian plane? North, south, east, and west. So it's on 30° west longitude, isn't it?
Yeah.
30° west. They're on the same longitude, but are they on the same latitude?
No.
Okay, let's say this one is this place is, say this place is 20. Of course, this is 20° north, while this one is on this one is 65° south. So you can see that they are not on the same latitude, isn't it?
Yeah.
They are not on the same latitude. They are on the same longitude, but not on the same latitude. Of course, P is on what latitude? 65° south, is it not?
Yeah.
While Q is on what?
Longitude.
Q is on what?
Latitude.
Latitude of 20° north. I labeled it now.
Yes.
20 degree north. So you can easily get the distance from P to Q without wasting time. Am I right?
Yeah.
If you are required to get the distance from P to Q, sorry, I just mutilated something. Let me make it better. Distance from P to Q. P to Q, can you see it?
Yeah.
P to Q. All you need to know is the angle between them. And like I told you, it's not a big deal. In fact, what I was just trying to tell you is if they are on different latitudes, just add those angles because all of them are start coming from the equator. But if they are on the same angle, subtract them. I will say that again, and I won't have to even make a fuss about it. If they're on different latitude, that's different. What I mean is different directions of latitude. Like one is north and the other is south. Add the angles. It makes a lot of sense because this one is 65. I didn't draw this to scale, so remember I did not draw this to scale. This one is 65 south, while the other one is 20 north. 20 knots. I didn't draw this to scale, so just an illustration. 20 knots. So what should you do to get the theta? This is P and this is Q. How do you do to get the theta, the angle between them?
65 plus 20.
65 plus 20. 65 plus 20. That if they were both north or both south, you have to subtract. I can easily draw it to explain to you. Let me show you, but let me give you the rule. Same direction, east. In fact, same direction, subtract. Different directions, add. Like east. What do you do?
Subtract.
West.
Add.
No, what I said east, subtract.
No. Subtract.
Not.
Subtract.
South.
Subtract.
West, east.
And add. Sorry.
Add. Once they are different, you add. North, south.
Add.
Once they are different, add. One is south, the other is north. Add. This is what I mean. One is south. The other is north. You will add. Let me tell you why you have to subtract when they are on the same side. I can use something. Okay, look at this one so that you see why. I just don't want to waste so much time, but you can see it. Let's see this one. I think I might just zoom it in a bit for you to see better. But that's just the rule. Look at this point and this point. So you see why subtraction it makes sense to subtract. Look at this point and this point. They are on the same longitude, isn't it?
Yes.
This longitude must be west, right? Let's see. East is actually on the eastern side of meridian. Let's say this is 40 degree east of meridian. 40 degree east of meridian longitude. And they are on the same longitude. Let's call this place A and call this place B. And you know, this, by the way, this is equator.
Yeah.
So both of them are on the same north, is it not?
Yeah.
A is on 35 degree north. B is on what?
65 degree north.
65 degree north. It makes a whole lot of sense to subtract. It just makes a whole lot of sense to subtract because one is not on the other side. You will see it. Assuming this is the equator, and this is that A, which is 35 degrees. You see, this is 35 degrees, and then I'm going to get the B now. Let me use a different color. Let me call it purple. I get the B now. B, which is what degree is P, by the way? B is
35.
65.
I'm sorry, 65.
65 degrees. You see why this thing is so easy. It's not a big deal. You just think, reason very well, you get it. We want to get this distance. We want to get this distance. By the way, this is B. This is A. This is B. I want to get this arc. This arc. This arc. So what must be this angle? From the equator, A is 35. From the equator, A is 35. Let me write it. 35 degree north. Latitude. B is also north. 65 degree north. So what do you think this angle we need to use is? This angle here. I'm going to draw it in blue. What will be the value of this angle theta? Because you agree with me, if you measure from here all the way to here is 65, and if you measure from here all the way to here is 35. So what is this angle theta in blue?
-65 minus 35.
Yes, it has to be 60. Theta must be 65
30.
minus 35, which is 30 degrees. That's what you're going to use. I'm just trying to tell you, if on the same side, subtract. Same north, north, subtract. Same south, south, subtract. Same west, west, subtract. Same west, east, subtract. But if you have north and south, add. South and south. South and north, add. West and east, add. It makes sense. So if you wanted to find the distance AB, are you still with me?
Yeah.
Well, so if you wanted to find length of AB, length of arc AB, is the same thing, theta over 360 times 2 pi r, isn't it?
Yeah.
That would have been, what's the theta? 30 over 360, isn't it? Times 2 times pi times the radius of the edge, 6,000. And we get the answer.
That would be.
Okay. You can go ahead and get it.
2,100.
Okay, let me write your answer. Since you found it, what did you say is your answer?
3,141 points.
Give it to three single figures.
3,140.
40 kilometers. Sorry. 40 kilometers, That's just the thing. So don't forget the summary. East, east, subtract. West, west, subtract. North, north, subtract. South, south, subtract. But west, east, add. North, south, add. Okay?
Yeah.
I think this is very, very easy. It's very, very easy. I just want to show you another thing here. Just a moment. All these values of r we're using here. What's even the radius of the earth? One more time. You can still see what I'm sharing.
6.
Yes. What's the radius of the earth? 6,000 kilometers, right?
6,000 kilometers. Yes.
Now that is the radius of all longitudes and the equator, because those are the ones that have complete full cycle. It's only the longitudes that have complete full cycles, and then the equator, the ones we call meridians, right?
Yeah.
Did you hear me? The ones we call meridians.
Yeah.
What are the meridians? All lines of longitudes, and then the equator. They are the longest of them. And I told you, if you remember, that the latitudes are not equal. The longest of the latitude is what? The longest of the latitude is what, if you like?
Is the equator.
Is the equator. Longest is the equator. So since latitudes don't have equal length, they won't have the same radius. Is it not? only the equator. Only the equator will have the same radius as the radius of the Earth. Let me call here A to B is the radius of the Earth. You know what I mean? Because this line is an equator. Do you understand what I mean?
Yeah.
Are you getting me? AB is equal to radius of Earth. Radius of Earth, which is what? Big R, which is 6,000 kilometers, isn't it?
Yeah.
But all these other latitudes, and also I don't have to say that the longitudes too are radius of Earth. Or the radius of the longitude are also radius of Earth. Radius of the longitude are also radius of Earth. All longitudes. So long as the thing is on longitude, is radius of Earth. Like this example we did. Where is this example? Let me show you. You see this example where we found P to Q. P to what?
Q.
So this example where we have P to Q. When we were doing it, we used the radius of the Earth. Okay, I want to look for the one we actually solved. Where is the one we actually solved? Okay. This one we're doing A to B. This A to B is along what? It's along a longitude now. Do you want me to zoom in?
Yeah.
It's along a longitude. That's why we use. That's why we use the radius of the Earth, isn't it? Because longitudes also are equal to latitudes, so it's the same radius of the Earth. But when we are talking about latitudes, distances along latitudes should be treated differently. Where did I draw latitudes so that you can see? Let me show you. Yes, distances along latitudes should be treated differently because they are not equal. So radius of latitudes are not equal. Let me get other values from here. You can see the center of this one is smaller than AB. Let me call this one P to Q. PQ. Or this one, I'm going to use a different color. Let me use purple here. Isn't it obvious that the radius is decreasing?
Yeah.
Let me call this one M to R, M to T. The radius is decreasing. So small r, you can call it R2, R3, R1, or R2. Why this one is the big R, which is the radius of the Earth. You get what I mean?
Yeah.
That of equator is the big R. Anything along equator, you can use the radius of the Earth, big R, because the radius of the Earth. But along a latitude, you have to use a different radius. So AB is radius of Earth. Yeah. Now, but for radius of latitude, you do a different thing. This is the formula: radius of latitude. Give me that formula again. You said you have you searched it out.
That would be R times cos theta.
Exactly. Where theta is the angle of that latitude.
Yeah.
Radius of latitude is equal to big R, which is the radius of the Earth, times cos theta. Where theta is the angle of latitude. R is radius of Earth. Radius of Earth. Big R is radius of Earth. Theta is what? Angle of latitude. Theta is what? Angle of latitude.
Angle of latitude.
Angle of latitude. Is that clear?
Yeah.
It's not a big deal. It's not a big deal. So without even wasting time, assuming this latitude is, let's say this one is 50 degrees south, while this one is 40 degrees south, what is M to T? MT or R3. Let me write it in purple since we are using purple. You know, sorry, I didn't pick the green. Let me use purple. Empty. Are you still with me?
Yeah.
We should be done. Empty, which is R3, is big R cos theta, isn't it? Which will be big R is 60,000, 6,000, sorry, radius of Earth times cos theta is, the theta there is 50 degrees. Do you understand?
Yeah.
That's for empty. But if we are looking for PQ, which is R2, PQ, PQ, which is R2, you know, and we're also going to use R cos theta. What's the latitude for that one? 40, isn't it? Whether north or
Yeah.
south is the same thing, it's just the angle you use. So that will be equal to 6,000, which is the radius of the Earth, cos 40 degrees. You know, that's how you find the radius, and then you can now use it for your calculation. Okay, so that this we can drive this home. Let me give you a question. Look at this one. Look at this one. Let's see if we solve it here. Are you ready?
Yeah.
We are required to find the distance from let me call this one K to Q. They are on the same what?
They're on the same latitude.
Interesting. Same latitude of 15 degrees north, isn't it?
Yeah.
But on different longitudes. One is 30 degree west. Remember, this is 30 degree west, while this one is 45 degree east. I hope you know, because this is a meridian. This is greenish, 0 degrees. Greenwish or greenish. Just a term in the UK. You get that? They are imaginary lines. They don't exist anywhere. You don't find those lines anywhere. It's just imaginary to define the positions of the Earth. You get what I mean? Okay.
Yeah,
So we want to find the distance of this arc. We need to first of all find the angle. They're on different sides now, isn't it?
Yeah.
One is east and the other one is west. In fact, the position of this one is 45 degree east on longitude, and the other one is okay, let me just write their longitudes. Their longitude, this is 45 degree east on longitude, while this one is what? On longitude, while this one is what?
30 degrees west on latitude.
30 degree west on latitude. Sorry, instead of writing the letters, I wrote angles. K and P. K and P. This one is 30 degree west. 30 degree west, also on longitude. All right. So, on the same latitude of 15 degree north, I would have made this thing to go to the north. Sorry. How do I redraw this so that it will actually look north? Okay, let me just redraw it so it will make sense. But it doesn't really matter. I would have just redrawn it so that it will look like actual north and south. You know, it should look like actual north and south. So we have something like this. You know, all right, remember the latitude is 15 degree north, the longitude that is. Okay, so what's the angle between them without wasting time? Theta.
That should be
Theta is equal to
that should be 75
75, because they're on different sides. One is east, one is west, so that's 75. 30 plus 45, that's 75 degrees. Okay, so we want to find the length of KP. Length of KP, arc KP, you know, length of arc KP, you know, is equal to theta over 360, isn't it?
Yeah.
Times 2 pi times radius. I want to write this radius because it's not really the big R we are going to use. I need you to see the difference. It's times radius. Are you ready? Theta over 360 times 2 pi times radius. Okay, but you know it's on a latitude. You understand what I mean?
Yeah, down same latitude.
On the same latitude, so the radius is different. It's not the radius of the Earth you're going to use. You know, you're not going to use the radius of the Earth. You're going to use the radius of this latitude. What's the radius of this latitude? R. Remember the formula I gave you? R cos theta. Do you remember?
Yes,
Okay, that would be.
Yes, I remember.
Yeah, 6,000 cos what? Where theta is the angle of the latitude. Cos 15. The angle of the latitude is 15. Do you remember?
Should I do this in radians or?
Use degrees, please. Use degrees. Anytime you are solving this, just use degrees. So what does it give?
That is 5,795.5.
5,795. Well, 0.5 you like. That's a small r. If you notice, it's smaller than the radius of the Earth.
Yes.
What's the radius of the Earth again?
6,000.
6,000. So because it is on a different latitude, it is going to be smaller. It's actually smaller than the radius of the Earth. So before now, you can apply the normal formula, theta over 360. I hope this is making sense.
Yes, it is.
So length of KP now will be KP is equal to theta over 360 times 2 pi r. So what will now be theta? The theta you are using, don't forget, 75, isn't it?
Yeah.
So 75 over 360 times what? 2 times pi times what r are you using? 5795.5. Okay, you can now give me the answer.
That will be 7586.
7586.3. Three significant figures.
Okay,
7590.
0590.
90 kilometers. You can always leave your answers to three significant figures, right? Except if it is stated otherwise. So the idea is, if it is on a latitude, you're not using the radius of the Earth. You have to first of all find the radius of that latitude. You get what I mean? And the formula is r cos theta, or radius of Earth times cos of that latitude. The latitude is 15. Whether north or south, it's just the angle you use. And then when you find out r, that is what you're going to use in the normal formula of length of an arc, theta over 360 times 2 pi r. I think that's cool. Isn't it cool?
Yes, it's cool.
All right. Okay. Okay. This question: an aircraft flew along the same latitude for 5 hours. So just read it out.
An aircraft flew along the same latitude for 5 hours at the speed of 250 meters per second. If it started at P, which is 40 degrees north and 60 degrees west, find its new position at the end of flight. Take R as 6,400 kilometers.
Okay. I think the best thing for you to do is to find the angle separating P and R. separating P and what and find its new position. Let's say the new position, find its new position. Let's call that new position M or so, whatever, right? Just find the angle separating P and M on the same latitude. That's 40 degree north. Maybe you could have just drawn something like that. We don't know whether they will be on the same side or different sides, so we really don't know. So, but you can just draw this to know what we need is just the angle. So this one is west, 60 degrees. Are you listening to me? So this is P. P is west. What's the thing again? 40 degree north and 60 degree west. And since it's on the same latitude, whatever M will be, will also be 40 degree north.
Yes, but we don't know what
We don't know what it will be, whether it will even be on west or south. So it might just be theta degree, whatever it is. So, but we can find the angle. We can do some analysis to find the angle. We can find this angle theta. Are you listening?
Yeah.
Because we can also get the radius. What color can I use? Let me use purple. We can get this radius of light, this arc PM, arc PM. So, but we need to find a distance of light. Is that not what you need to do first?
Yeah.
Okay, distance or length covered is equal to 5 hours at a speed of 250 meters per second. Distance is speed times time, isn't it?
Yeah.
Were you thinking about that?
I thought about that, but I thought I'll do that later.
Later, okay. Speed times time. So the speed is 250 meters per second. You need to, because it's in hours, so let's change it to kilometer per hour, because the dimensions are given in kilometer. So change 250 meters per second to what kilometer per hour? How do you do that? This is a standard question.
Yeah.
Change 250 meter to kilometer. That would be 250 divided by 1000.
Yeah.
Per hour means divided. Change second to hour. That would be 1 over 3600. Do you understand?
Yeah.
That is divided by 1 second to hour. Are you sure you understood what I did?
Yeah, and that's what you did.
Okay, beautiful. Because this is in kilometer, this one is now in hour. Remember, this per means divided. That's why I wrote the division here. 250 meter is 250 over 1000 kilometer. That's 2 meter to kilometer. 1 second is 1 over 3600 hour, and it is per means division. Okay, let me even write it in red so that you see how all of that follow. What color can I use now? What's the best color? Perhaps purple will be fine. This bar in purple will now be division. Simplify this.
Okay, that'll be
250 over 1000 times 3600.
That's 900.
Is that 900?
Yeah.
900 kilometer per hour. Do you understand?
Yeah.
I hope that's clear.
Yes.
Alright, so we have the distance. So since we now have the distance, that's the length of the arc. So length of arc is that. I think it's making sense.
Yeah, it is.
Length of arc PM is is equal to 900 kilometers, 9,000 kilometers. Did you get that? 9,000 kilometers. That's length of arc PM. So you can use that to find the angle. You know? Isn't it? So you know, length of PM, arc PM. All right, without even wasting time, you know that will be equal to 10 over 360 times that. So 9,000 is equal to theta. We don't know, theta over 360. Okay, by the way, this is on a latitude. So we need to find the radius of that latitude. That's what we use for our R. You know what I mean? Let's find the radius of the latitude. Radius of latitude 40 degree north. R is equal to R cos theta, which is R is 6,400. You know what I mean?
Yeah.
Cos 40. Give me the answer. 6,400 cos 40.
That'll be 4902.6.
4902.68.7 kilometers. So that's what we're going to use for that. So that will now be, we do 9,000 is equal to theta. We don't know. I can write it in purple. Theta over 360. Yeah, 360 times 2 pi r times 2 pi r. That's 2 times pi times r. What's r we are using? 4902.7. So you can simply get theta. So theta will be 9,000 times 360 divided by 2 times pi times 490.7. What does it give?
105.18.
105. So let's just use 105. 105 degrees. Interesting. Interesting. I like this. You need to be careful. I like this. It just brings out something I wanted to show you. 105 degrees, right? Are you listening to me?
Yeah.
Theta is 105 degrees and P is 60 degree west. So maybe I should do a simple sketch for you to see the point, because it is actually on the other side. If you like, you will get it. It's actually on the other side of direction. It must be on the east for it to be up to 105. If it was less than 60, okay, maybe I will have to do a sketch for you to see. You know, this is the way it is. This is 60 degree west, right?
Yeah.
And this angle is what? 105. 105. You know, remember this is what? This is P, and this point is K. The angle is 105. If we started from the Greenwich meridian, Greenwich would have been somewhere here. So this angle is actually 60. Here is 60. Are you getting me? 60 to the west. So the remaining one must be what? This is 60 to the west, while this is Greenwich, which is 0. So the remaining one must be what? The whole angle is 105.
45.
45. So this other angle I'll put it in a different color. Maybe what color can I use? Purple. This other angle, we don't know. Let me call it alpha. Alpha must be equal to 105 minus 60. You're getting what I'm doing?
Yeah.
Which is 45. So K, so what's the position of K? 45 degree east, isn't it?
Yes, it's 5 degrees.
So position of K will be, you said the latitude first. Both of them are on 40 degree north, and then it is on 45 degree east, isn't it?
Yeah.
Position of K. Okay, by the way, I called here 0. All right. It's clear, we got the angle, that whole theta separating them, 105. And we know that the other one is 60 degree west. And the angle is 105, is bigger than 60. So the remaining part must be on the eastern side of the longitude. So 105 minus 60. I think that's clear. 45.
Yeah.
So K is 40 degree north, 45 degree east. Alright, so you can try this. I have to let you go. You can try this one, this practice question here. Can you read it out? So I will just let you go. Just read it out.
An aircraft flies along the same latitude. An aircraft flew along
The
same
same.
latitude for 3.5 hours at a speed of 3 meters per second. If it started from the point Q, 15 south and 5 degree west to point K, find the position of K.
All right. I think it's similar to what we did, right? Okay,
Yeah, it is.
that's cool.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.